If I were to create the model, for example, of this platform, if I were to model it as a beam, here is the centroid line, here is the centroid line, here is the centroid line, this here is also a line. Normally, the first model you make of this assembly is using the beam element, and then you study this here. What happens at this joint? There are many ways to do this. One of them is you consider a node here, consider a node here, a node here, and a node here, and this here is the node of your model. We will talk about that later. But look at that, already doing a review of the future. What happens here? What are we going to detail? What are we seeing here? What happens is this, if you take this joint here. Oh, check out the joint we're talking about. It comes here. Come here. This is that joint there that was a single point, you see. What does the guy usually do? That which was a point, he makes an entire detailed mesh here, right? Later on, we will talk a lot about that there. In this, he manages to capture the behavior of this local byte, right? The big fatigue problem that occurs in these joints happens exactly here because of this local byte. This local byte we're talking about is exactly what's here. Well, look, this is what we're discussing. The beam element, it doesn't capture this, but if I make a beam model, I can take these nodes here, get the displacement values, and impose them as a boundary displacement right here. I take this node here. This is a modeling technique, you see? I take this node here. This here is a modeling technique, right? I enter with the displacements x, y, z and the rotations, and then this structure works. Or another technique is to make the beam element from here to there. The beam element, look, I connect this here. This here is called the rigid element. I create a global structure, but I only represent this joint. This is very common to do in the corner of a bus window, for example.